Hello, we are now starting chapter 7. There are 5 sections in this chapter that we have to cover, and each one is important. So please pay attention and try to make sure that you know this stuff. So we are going to write some identities which we have already seen and some which are new. But you don't have to memorize each of them. I will highlight, or I will put a star in front of the ones that you need to know or you must know. So we call them fundamental trigonometric identities because these are the basic identities that, like, if you are taking a course in which you are learning trigonometry, you must know these. So the first one is that cosecant of x is 1 over sine x. Or in other words, 1 over sine x is cosecant x. And also 1 over cosecant x, CSC, that's the abbreviation for cosecant. So 1 over cosecant x will be equal to sine x. So these go both ways. In the same way, secant of x is 1 over cosine x. So if you see 1 over cosine x, you can write it, or you may write it like secant x. And if you see secant x, you can write it like 1 over cosine x. So like the same thing I wrote for the secant. So 1 over secant x, if you see, that can be written as cosine x. Then we have that cotangent is equal to 1 over tangent x. In the same way, tangent of x can be written as 1 over cotangent x. So in other words, if you see somewhere 1 over cotangent, you can write it as tangent. The next thing are the tangent is equal to sine over cosine, and cotangent of x is cosine over sine. So these are the reciprocal identities. These you have to know. Pythagorean identities. In the Pythagorean identities, if you know this one, so this is kind of a must. Now these other two, if you memorize them, it's good. But if you don't, then you have to remember one thing, how to get them from the first identity. So I will show you that. So let's say this is number 1, this is 2, and this is 3. So I numbered the identities, Pythagorean identities. Now if I divide one, so it means identity 1 by cosine square t. So what will I get? So this will give me sine square over cosine square t plus cosine square over cosine is 1 is equal to 1 over cosine square t. What is the first term? This means we have tangent square t plus 1 equal to secant square t. So see, we got our second identity. And in the same way, if instead of dividing by cosine square t, if you divide by sine square t, you will get the third identity. So if you memorize this first one, remember the first one, and if you need to use the other identities and you don't remember, you can always find them from this initial identity. Next are even odd identities. Now an even function is a function which is, we say, is symmetric about the y-axis. So in other words, if you see something like this, f of negative x is the same as f of x, then we say function is even. It means if at x is equal to a, the value is b, at a the value is b, then at negative a the value is also b. So for example, if you recall the cosine function, it goes like this. So it is symmetric about the y-axis, so this is an even function. So which means cosine of negative x is equal to cosine x, so this is even. So we say cosine x is an even function. But if we have a situation where we have like sine x, so sine x, if you notice, was like this. So we say it is symmetric about the origin. Okay. So in this case, what will happen? F of negative x will be equal to negative f of x. So if you recall, that's what happens with the sine and the tangent. So this is an odd function. This is an odd function. So these are again the ones that you have to remember, all three of them. Now these co-function identities, I would not recommend that you memorize them. There will be a formula later in this chapter that you can always use that to get from left side to right hand side. Okay. But by the way, this is not too bad in the sense that what we are saying here is that if this angle is theta, the easy way to understand these is then this will be equal to 90 minus theta, or pi over 2 minus theta. Okay. So if you recall, the sine of theta is the same as cosine of pi over 2 minus theta. Because if this is A, this is B, and this is C, then sine of theta will be A over C, whereas cosine of pi over 2 minus theta will be A over C. And similarly, the cosine of theta will be the sine of pi over 2 minus theta. And the tangent will be, so tangent of theta will be equal to cotangent of pi over 2 minus theta, and so on. So you should be able to figure that out. Okay, now the main goal for especially this section is to verify identities. Now what does it mean? Now these are basic identities, these the ones that we just saw, and so that's why I say I ask you to memorize them, because you will use these basic identities to verify or to simplify. There are two different things. One is simplifying an identity, and then another is verifying an identity. In simplifying the identity, you will be given or to simplify some expression, you will just have no equal to sign there. But in verifying identity, you will have equal to sign. So you have to, verifying identity means show that the left hand side and the right hand side give you the same answer, or they are the same. But simplifying means just take the quantity and use one of these basic identities, or maybe more than one basic identities, and simplify your expression or write it in a simplified form. So here is the first example. By the way, here note, to simplify a trigonometric expression, we will use algebra, which means factoring, common denominator, or multiplying by the conjugate, etc., along with the fundamental identities. Okay, so first example here, so this is saying simplify the following expression. So you will, what comes to mind here, well, these are two fractions which are being added. So whenever you have two fractions or more than one fraction being added or subtracted, you should do a common denominator. So what is the common denominator here? So here you see we can write this is equal to, Okay, I'm going to take the common denominator, which is cosine of theta times 1 plus sine of theta. Okay, so what happens now? On the top, I have sine theta in the first place, which gets multiplied by 1 plus sine of theta. Plus, so we have already cosine theta here, and it gets multiplied by cosine theta. So that this becomes equal to, now we will expand the top. Do not expand the denominator. Just leave it in factored form. On the top, I get sine of theta plus sine square theta plus cosine square theta. Now note that these two from our identity will be equal to 1. Okay, so we can write this is equal to sine of theta plus 1 over cosine of theta times 1 plus sine theta. And why did I write that? I can say on the side, I can say because. I hope you guys know this is the symbol for because sine square theta plus cosine square theta is equal to 1. That's why we could replace this quantity by 1. So this will give me, well, you should be able to see that the top and the bottom factor cancel out, or if you want to do one more step here, then this and this cancel out, and we are left with 1 over cosine of theta, which is secant of theta. So we simplified it to secant of theta by using our identity. So we have a bunch of these. Let's see how we can do them. So cosine of x times cosecant of x over cotangent of x. Now remember this thing. This is again a hint. Whenever you are given an expression or an identity which involves secant, cotangent, and cosecant, and even tangent. Okay, if you are given cosecant x, secant x, maybe cotangent x, tangent x, and no sine or cosine, you can leave them as they are. But if you have, along with these quantities, you have the sine or cosine present, then the best way to do it, convert everything into sine and cosine. So if you look at B, we have a cosecant x and then we have the cotangent x, but then we have the cosine x here. So the best way to do is to write everything in the form of cosine and sine. So this will give me, this is equal to, so cosine x remains as cosine x, but maybe let me first do one step here. This will make it easier. So I can write it like 1 over cotangent x. I hope everyone agrees with this, because this is saying that since if you have 2 times 1 over 3, you get 2 over 3. So it means if you have 2 over 3, you can write it as 2 times 1 over 3, or 1 over 3 times 2. You can write it like that. So that's what I did, and now I will convert cosecant. So cosine x remains as it is. Cosecant x is 1 over sine x into 1 over, so cotangent is cosine x. Again, how you want to do it. You can also say cotangent x is 1 over cotangent x is tangent x. So we get cosine x into 1 over sine x into sine x over cosine x. But cosine and cosine cancel, sine and sine cancel, so we are left with 1. So this simplifies to 1. Looking at number C. Well, we don't know what cosine cube x, how I can write cosine cube x. I have an identity which can change this into cosine, but think about it. We don't want to get into complicated things, right? We want to make it simpler. So if you look at these two terms, the cosine x is a common factor. So we can start there. We can factor out the cosine x. What I am left with is, on the first term, I have cosine square x left, and then from the second I have sine square x left. But what is this quantity? This is 1. So we get cosine x as our answer. Okay. The next one, tangent x over secant of negative x. So remember, in this also it will be easier if we convert to sine and cosine. So I have tangent x, which is sine x over cosine x. So you can also do it like this, sine x over cosine x whole divided by secant of negative x. Secant of negative x means 1 over cosine of negative x. But cosine of negative x is the same as cosine of x. So we have it that sine of x over cosine of x divided by 1 over cosine of x. And again you can write on a side, because cosine of negative x is equal to cosine of x. So this can now be written as sine of x over cosine of x times cosine of x over 1, which means sine of x, because these two cancel. So next one, secant x is 1 over cosine x and minus cosine x whole divided by tangent x, which is sine x over cosine x. Now we can simplify the numerator, make it one fraction, and then work the numerator and the denominator. Or in order to simplify this, if you recall, somewhere in algebra course you must have learned, because look, the common denominator of the top is cosine x and the common denominator of the bottom is also cosine x. So if I multiply the top by cosine x and the bottom by cosine x, what will we get? So this gives us, so when I distribute the cosine here, I get 1. And when I distribute to the next, I get minus cosine square x. And at the bottom, I have sine x. Okay, so from here, what can we do? So now, if you remember this identity, sine square x plus cosine square x is equal to 1. So if I subtract the cosine square x, I get sine square x is equal to 1 minus cosine square x. So the first fundamental identity can be written in 3 different forms. So one form is the given, this form, another is this form, and a third form is, which we are not using here. The third form will be cosine square x is equal to 1 minus sine square x. So now that we have this, so I can now say that 1 minus cosine square x is sine square x. Because of this one, we get sine square x on the top here, and then at the bottom I have sine x. So now I can cancel the one of the signs, so I end up getting sine of x. Now these problems are something that you might have to spend a little bit time to think about and understand, because often there are questions in the exam from this section. So let us see number F. So what should we do? Well, makes sense to take the common denominator and get it into one fraction, but before we do that, should we change our cosecant and secant to sine and cosine? Yes, we should do that. So I can think of the first one as sine of x times 1 over cosecant of x plus cosine of x into 1 over secant of x. But 1 over cosecant is, this thing is sine x, and this thing is cosine x, so that our expression becomes sine x into sine x plus cosine x into cosine x is equal to sine square x plus cosine square x. But what is that? That is equal to 1. Now, is this the only way we can do it? No, there are different ways to do it. So you may try to do in any way you want. As long as your math is correct, your algebra is correct, and you are using the correct trig ratios, it will be considered correct. Okay, I will stop here. The next part of section 7.1 is about verifying identities. So we will do it in the next video.